So once again, I want to welcome you. Good morning. Uh, I believe you are doing well. Uh, so we have no time to waste. Maybe others will join us since the lecture is being recorded. Uh, they will be able to go through the video. I can see Honey has joined. You are welcome.
Thank you, sir. Good morning, sir.
Good morning.
Yes, sir.
Um, yeah, others are joining now. So let's hit the ground running. Um, Let me share my screen. So, um, if you recall, last week we started this chapter and we tried to make it as simple as possible. Um, I believe those who missed that lecture by now should have watched the video from the beginning to the end. If you really want to continue to be on the same page with us, but if you are just joining at the middle, you may uh, have challenges because we will not be able to go back and repeat things that we have talked about. Uh, so, as usual, I will give the lead, and Kafayat will come in with more emphasis or additional uh, input, and then Honey will take us through review questions. Uh, so that will be the pattern. Notwithstanding, I encourage you to interject at any point in time to uh, share your views if necessary, or ask questions if you have any. So I'm trying to save time, but at the same time, I can call you to ask you one or two questions uh, at any stage, at any point. So make sure you follow. Uh, you could be randomly picked to answer one or two questions. So uh, that would tell me whether you are fully with us or you are, you know, partially, or even, you know, not with you are not with us at all. So even though this is a virtual class, it's advisable that you uh, devote this time fully to uh, the purpose of this lecture. So we started discussion on the fundamentals of probability theory, and I remember very clearly that I listed a couple of concepts that you need to understand. So we talk about probability, you know, by definition. So we define it, and then we also talk about the laws, or the rules, or the axioms, of probability. So, of probability, we discussed that last week, and then we talked about the uh, concept of random variable. You know, talk about the concept of random variable and how we use it uh, in probability. Uh, and then we talk about the probability distribution, you know, what it means, and when you say you have probability distribution, you should be able to recall how we emphasize that in the probability distribution, you have the probability value for each possible outcomes in the sample space, or in the experiment. And the sum of these individual probabilities must add up to one. So that means you have a probability distribution. Then we talked about the joint probability distribution, joint probability distribution. We also talk about the marginal probability distribution. So I call this one JPD. We will continue to talk about it in our subsequent lectures. We talk about the marginal, the MPD. So uh, this represents the coverage of our discussion last class. So I'm not going to waste time. But one thing you should never forget is the definition that I give to probability, as the ratio, which is just a fraction. It represents the number of favorable outcomes over the number of possible outcomes. So always remember that, and it's a measure of, of certainty, you know, the chance, the likelihood of an event occurring. So today we will be looking at three other concepts, basically. One, we'll look at the concept of conditional probability, so CP. We will also look at the concept of two, conditional independence, conditional independence. So we can call that also C high, and then we will round up the lecture with the Bayes theorem, which is very central to this course. So this is the plan for today, and everything we talk about, though summarized, you can see them in the lecture notes. Uh, but this discussion will be more elaborate, just to help um, make sure that everybody is on the same page, particularly our colleagues from the linguistics department. So that's once we are able to cover that, then we'll be able to uh, say we have finished this chapter 2 of the lecture manual. I don't know if Honey and Kafayat will now have time to take you through. That may be in another. You might arrange a special class for that, which will allow you to use R. So they will be able to take you through the R application, the examples that you have here, and then you see uh, how you can apply probability concepts in the natural language processing. So you have example here, and the R package that you will need to use. So you will also be able to draw this kind of thing. So this practical session will be done by my colleagues. So you might need to arrange um, a special, not our regular Friday meeting, maybe a special uh, uh, time to be able to go through this practical uh, side of it, line by line. So they will announce that it could be virtual, it could also be physical. Is that okay, Kafaya and Honey?
Okay, sir.
So I didn't hear Kafaya.
Yes, sir.
Maybe it's not okay.
Yes, sir.
Okay, so let's go to what we have today. Like I said, but before I continue, any matter arising from uh, this concept that I said we covered last week, um, any matter arising, no, uh, anybody from linguistics, are you around? Nobody is responding. Uh, Nobody from linguistics has joined yet. I'm asking, is it that nobody from linguistics has joined?
So I think they said they are having an exam this morning.
They have exam again? Which exam? Okay.
They said today.
I thought the exam was last week Friday.
They sent a message again today that some of
Okay,
them having exams.
okay, no problem. So we continue since the lecture is uh, is available on you know, to be available on the YouTube. So let's start with the concept of conditional probability. Um, and better demonstrate this with a very practical example, to help us. And by the way, if you look at what you know the way it is defined here, so you have conditional probability is the probability of one event given that other event has occurred. So definitely uh, you have if you have two events A, what's happening? Sorry. Oh, sorry, my pen is not writing, so let me know why it's not writing. Okay. So I said we are discussing conditional probability. And I was saying if you have two events, A and B, it's possible if you like the example we gave, A could be event of, say, tossing a coin. This event could be event of throwing a die. Um, you will agree based on our discussion last week that event A occurring does not depend on event B. What will appear when you throw the die does not depend on what appears when the coin was tossed. They are said to be independent. So two events are independent. So we use this to say they are independent. So two events are independent when the occurrence of one does not affect the occurrence of the other, does not influence the occurrence of the other. So in these two, throwing a die, whatever outcome appears is not influenced by what happens or what will happen when you throw or toss the coin. So they are independent. But there are instances which we are going to look at today. Suppose you have uh, in a class, let's say this is our class, we have 8 students. We have 8 students. And they are made up of male and female. You have 5 males and you have 3 females. And then our interest is to select, so we want to select 2 students. Of course, one after the other. So without putting the first back. So we say without replacement. So remember, we are selecting just 2. So if we ask this question, number 1, and we say, what is the probability that the second student is female? So, I mean, depending or regardless, depending on who the first student was. That is the question. So we have 8 students, 5 are males, 3 are females. And we are selecting 2 students without replacement. So what that implies that if you select the first one and it's a female, for instance, by the time you are selecting the second one, for you to get a female, you will not, we will no longer count the female you already selected in the first selection. So the implication is that the second selection is conditioned on what happened in the first selection. And this is where conditional probability comes to play. So this example is to illustrate that there are situations where what will happen next depends on what has happened before, or what is happening now depends on what happened previously. So you have conditional uh, uh, you you have conditional probability of situation. So you could also figure it this way. I like to use the tree diagram. So this is your first selection, which could be male or female. And then when you now come to your second selection, if you had male in the first, then you could also have male in the second or female in the second. If you had male female in the first, you could also have male or female in the second. So this is what you see in the first, so which is what you see in the second. If you now go back to the question, which is that you are looking for the probability that the second student is female, depending on who the first student is. Remember, our interest is the second student is female. So second student can be female here. Second student can be female here. So there are two cases where second student could be female. So you could have case one, that's when the first student is a female, referring to this. So I call this one case one, and I call this one case two. So case one refers to first student so let me so first student is wow my this thing is not writing it. I don't know. Okay, so I think it's all right now. So first student is female, and case two, first student is male. Yes, first student is male. So first student is male. Take note. So in essence, if we are to compute this probability, what is the probability that the second student is female? Then we will need to compute the probability for case one, and that is saying that we want the probability of the second is female, given that, yeah, sorry, I'm referring, this is case one. The second is female, given the first is female. That's the probability we are. So because we are interested in the second being female, regardless of what the first is. So we want this probability 1. 2, we also want probability of the second is female, given that the first is male. So these are the two probabilities that we want. So how do we compute this probability? So first of all, before we can compute, let's case 1, then we need to know the probability of selecting female in the first. And what is the probability of selecting female in the first? Remember, in the class you have 8 total, and then you have male to be 5, and you have female to be 3. So to select female in the first, then you have 3 chances out of 8. So which means for this probability, for female to be selected in the first, this will be 3/8. So that probability is what we call probability of female. That is 3/8. Similarly, probability of male, of selecting a male in the first, that will be 5/8. Now we are going to the second. So let's go to case 1. That's probability the second is female if the first, given that the first is female. So that shows that if we are to select female here, and I want you to listen very well. Remember, we've selected female in the first, which means the female has reduced by 1. And that also means the number of students remaining has also reduced by 1. So we are left with 7 in the class and left with 2 females. So therefore, to select female in the second, given that female was chosen in the first, then the probability will be 2. That's over 7. So this is 2/7. This is conditional probability. Let's come here. So I'm going to clean this now. So in case 2, remember that we've selected male in the first, right? So the only thing that has changed is that the number in the class has reduced by 1. So we are left with 7. And for us now to select female in the second selection, we have all the 3 females still remaining. And In that case, the conditional probability would then be 3 out of 7. So this i- is, of course, you can, you know, take this to fraction. So this is equals to 0.286. This is approximately equals to 0.429 or thereabout. So this is a simple application of conditional probability. How the outcome, how the current outcome, the probability. Where is that coming from? Sorry, is that coming from me? Hello,
Hello, sir.
is that coming from me?
Not at all, sir.
Where is it coming from?
I really cannot say, sir.
Okay, but did you hear it? The maybe somebody is dancing somewhere. Okay, so any questions so far? Any questions so far uh, on this discussion? Any question? Timothy Oyeleye, I can see you. Any question?
No question, sir.
No, sir.
Okay, there are two Oyeleyes. That's good. So, how about Damola? Adedamola? Adedamola maybe is
Yes,
not.
sir.
Are you in the class?
Yes, sir. I'm in the class, sir. I'm
Are
fine,
you
sir.
are you able to follow?
Yes, sir. It's just that
Yes,
I
grudgingly.
I want to maybe I'm not right. The question
Yeah.
is it going to be, or is it, are we going to use the additive law to get the final answer, or this that will leave it?
Yeah, the question is, what is the probability that the second student is female, depending on who the first student was? So we consider all the possible cases. So
Right, sir.
I know where you are going, but we will come to that.
Okay, sir.
But
Thank you, sir.
to address this question, that's why I underline the fact that for now your concern is second student being female.
Email. All
But
right, sir.
for second student to be female, then two things could happen in the first. So we look at two possible, uh, for the second to be female, there are two instances where the second could be female. It's
All right,
female
sir.
here, it's female here. But what could have happened in the first? Again, the first could be female or male. So that's why we use case one, case two. Is that okay?
Yes,
Is
sir.
that okay?
Yes, sir. Yes, sir.
Okay. If it is
Thank you, sir.
okay, I will give the class a simple exercise now, and I want everybody pick your biro, pick your pen, pick your paper, and then answer the other question, which I just want to twist slightly. So if I now say this is second question, and I'm interested in what is the probability that the second student is male. Just change this to, so number 2 question now. I only want to change this to male. I hope that question is clear. I hope that question is clear.
Yes, sir.
Great. So what is the probability that the second student is male? So if you also use my illustration here, then I give you 2 minutes to work out, maybe 2 or 3 minutes to work out your answers. Look at, since we are looking for, yeah, we are looking, I hope you are working. Your 2-3 minutes have started counting, so I'm going to remove this now. That means everybody will have to respond to that. So keep on doing your stuff. So this, remember, this probability is 3/8. And this is 5/8. So for your own tool, you can also look at the cases that are possible. Look at the cases that are possible and tell me your answer. I believe you are working. When you are through, raise up your hand. So we want to calculate that the second is male, actually. So this is going to be so this the second is male. This will be M. This will be N. We want the probability that the second is male. The second is male. Who has finished? Who has finished? Who has finished? So to help you, if the second must be, okay, Ade Lucy, good of you. If the second must be a male, then 2 things can happen. The first can be male, so we could have this scenario, and then we could also have this scenario. We could have this scenario, or we have this scenario. So this first one, this is the probability. That's this, the probability that the second is male, given the first is male, is referring to this. This one is given this, the second is male, given the first is female, is referring to this. So type your answer in the chat menu. Let me see what you have. Type your answers in the chat menu. Type your answers in the chat menu. Let me see what you have. Let me see. Have you typed? Have you typed your answers? Adedamola, okay, I can see your own. Who else? Who else? You have to participate in the class. Very important. Adelucy, I can see your hand is up. Adelucy, I can see your hand. Oyeleye, I can see your any question or you yeah. Okay. So let's look at it together. Once you have submitted, you can put down your hand. Except you want to say something, then you can say. Except you want to say something, you can say. So let's look at it together. So if the first uh, as is male as you have here, the first is male, then selecting male in the first will have probability of 5/8. But in the second, if you are selecting a male, then the male number will have reduced, and so you are going to have only 4, and then the total number of students also will have reduced. That will be 4/7. So if you got that one, that's good. 4/7. In the second, remember, you are looking at a case in which the first is female. So female has 3/8. If the second is going to be a male, there are still 5 males, only that the total now has reduced. So that is 5/7. Of course, this is 0.714. This is 0.571. I believe most of you got this correctly. Toyin, are you still there? I can see your hand up. Toyin Adelusi, Toyin.
Yes, yes, sir.
Is it that you are asking a question?
No, I forgot to turn it off back.
Okay. So, I believe this example is able to demonstrate in practical terms what conditional probability, what it means and how is applied. So the other concept I would like to talk about, is the concept of total probability, which which is closely related to what Adedamola talked about, and we can demonstrate it here now. So, suppose I want the probability of the probability that the second is male this time around. So if I want the probability that the second is male, Adedamola,
Yes, sir.
so you are now in the picture. I want the probability that the second is male. You know what led us to this was that we were looking at the probability that the second student is male, depending on who the first. So regardless of who the first, right?
Yes, sir.
Now we are now looking at the probability that that the second is male. So
Okay.
this, how will I be able to answer that? Adedamola, is like you've gotten it now.
That's when the additional rule now comes in.
Eh?
That either I think it will be that's when the additional rule now comes in. That is either when the first it
Is it
is male when male had occurred, or when female had occurred.
so? Are you using or you are using hand? Second is
Oh,
female. You are looking for probability. Think very well. You are looking for the probability that the second is male. So the second is male here, isn't it? The
yes, sir.
second is male. Eh?
Yes, sir.
So you are going to use hand because you have this and this. So you have to you 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 have to add up the two of them, and that will give. This is what that leads to the concept of total probability. Eh?
Yes, sir.
So if I'm looking for the probability that the second is male, then I have to look at this and this. It's not about all. And therefore you are looking for this becomes, I mean, so the probability that the second, sorry, the probability that the second is male is then going to be the probability that the second is male given first is female. So times probability of first is female. I'm going to show you. So if you come back here, so you are talking that the second is male,
Okay.
given that the first is female, right?
Yes, sir.
And then so you are talking of this this probability, so multiply by the probability of female. That gives you the first part plus the probability the second is male, giving first is male times probability of first is male, which is looking at the probability is looking at this one. So it's looking at this probability. Second is male, giving first is male. This probability multiplied by the probability of male. So this is what we call total probability. So this then becomes, if you look at this, is 5/7. That's the conditional probability multiplied by, that is, this is 5/7. This one is 5/7. Sorry. I'm one class, you see. So this is 5/7. This is 5/7, and this is the probability of female in the first. So we can now just substitute. So 5/7 times 3/8, that's female in the first, plus, second is male, giving first is, that's 4/7. 4/7 times 5/8, and that gives us 15/56 plus 20/56, and that adds up to 35/56. Well, you can take it to decimal 0.625. So this is the probability of the second being male. This is what we call total probability. And we need this total probability when we come to the Bayes rule. And so I will remind you when we get to the Bayes rule. But it's a concept again that you must understand, the concept of total probability. So which is simply looking at, if you are considering the second, we are looking for male in the second. Then we have to look at all cases, where you have male in the second. So you have to look at all cases in the first where you have male in the second. So, as we did before, let me now ask you, suppose you want the probability of second is female. I want everybody to compute that. Everybody compute that. The probability of second is female. You already have the results from our from the previous discussion. So, which means you are going to add up the result of the two cases that we consider. So, for you to have female in the second, so you are going to look at this, and you are going to look at this. So which will mean you are going to look at if we start from this one, so you are going to look at the probability of female in the second, given female in the first, multiplied by probability of female is first, plus probability of second is female, given first is male, times probability of male. Are you able to do that? Tell me your answer. So you follow the same procedure to get the total probability. What's your answer? Quickly. Damola, you have not done it. Yes. Oh, it's not. Yeah, somebody said 21/56. Excellent. Who said that? Who got that?
I'm doing, sir.
Okay, Tony, excellent. Timothy, you are raising up your hand. Timothy, any question or any comment? Okay. Yeah, so I'm happy that you all got it. So the correct answer actually is 21/56. 21/56, and that is 0.37 0.375. 0.375. Now, what does that tell you? What does that tell you? Look at the probability of, and I want somebody to interpret this. Maybe I've not heard from Adetono. Adetono, are you there?
Yes, sir.
Have I heard from you? Maybe my memory got lost.
No, sir.
It's not okay. Okay, so I'm engaging you now. the probability of having male, of selecting male in the second, what is that probability? This is it here.
Hello, sir.
Hello, yes, can you hear me?
Yes, sir. The total probability of second is male, Abby.
Probability that the second is male. What is that total probability?
35/56.
Yeah, so 0 point what? 625.
0.625.
Okay, what is the probability of second, no, of selecting female in the second,
That's 21/56.
which is 0. How do you
0.375.
how do you interpret these two results?
Okay. The probability of second is male is greater than the probability of second is female. So the
So
probability of the second male occurring
yeah.
is more than the probability of the second male occurring.
So which means, it's not just saying more. It is more likely you have higher chance of
Okay.
selecting a male in the second, right? The
Yes,
chance is
sir.
higher of selecting a male in the second. No, but the chance is lower. So if you are betting, for instance, you are betting, no, I'm not encouraging you to go and bet, but if you are betting, so you can use probability to know the chance you will win or you will lose. So
Yes, sir.
if you are aiming at, you know, uh, a male in the second, then your chance is high. That's what this result is saying. But I also want two people to know something now. If you go back, if you go back, yeah, to okay, uh, if we go back here, what is even the probability in the first selection? Maybe here. What is the probability of selecting a male?
5/8.
Even in the class, what is the
5/8.
5/8.
5/8? And what is the probability of selecting a female?
3/8.
3/8.
3/8. So uh the 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 implication is that you even the chance is higher because you have more males, right? Because you have more males in the class than female, and that influences the total result, in a way. So two concepts have been explained now, and I believe they are clear to you. One concept of conditional probability, the concept of total probability. Because of our time, let's move to another very important concept, and that is the concept of conditional independence. And I'm also going to demonstrate this with example that will make it, that will drive home the point. Conditional independence. I want you to know this very well, because in this PGM course. It's a very a major, very important concept that we must know. Uh, I've talked about independence. No, when two events are independent, it simply means that the occurrence of one does not influence the occurrence of the other. Then what do we now mean by conditional independence? So before is defined in the lecture note. So if you go to the lecture note, so independence, no, is simply defined as two variables being, you know, in, independent if knowing one does not tell us anything about the other. So uh, one occurring does not, give us information or has no influence on the other occurring. So, and I've you have a simple example here. If you are tossing two coins, so the appearance of a head in one does not affect the appearance of any other outcome in the second. But this is where we are going, conditional independence. And that says that two variables are conditionally independent if they are independent given a third variable. So I'm emphasizing this. For you to talk about conditional independence, you are actually going to be talking about three variables. So we are going to be talking about three variables. But if you are talking of independence, just independence, then you are talking about two variables. So that is, those two variables are, they have nothing, they are not influencing one another. They are truly independent. But for us to talk about conditional independence, then there is an intervening variable. So there will be three variables in question. So for purpose of explanation, let's say again in this class where we have event A to represent the student woke up, the student woke up late. B, the student missed the bus. And event C, the student arrived late to class. I want you to look at those three events uh, very well. A, the student woke up late. B, the student missed the bus. C, the student arrived late to class. Let me ask Oyeleye Timothy. If the student missed the bus, what could have happened?
Because the student woke up late.
Good. Let me ask Toyin. Toyin, are you there?
Yes, sir.
If the student arrived late to the class, what could have happened?
The student missed the bus.
Excellent. The student missed the bus. So you can see that somehow these three events, they have relationship. True or false? Who is responding?
True, sir.
True.
True. Oh,
True.
so, true. They
True,
they
sir.
have relationship. So first of all, we are going to consider two types of relationship that we can establish from here. One, we call it direct dependence. In the direct dependence, no conditioning. So we are going to look at that direct dependence. And that is simply saying, if you know the student, just like I asked, if you know the student woke up late, if the student woke up late, which is A, then it increases the chance that the student will miss the bus. So waking up late can influence B. And missing the bus can also lead to the student, arriving late in the class. My pen is not working. Let me address that. Okay. So we can see direct dependence. This diagram is showing direct dependence, which means waking up late can lead to you missing the bus. So missing the bus is a function, right? It's influenced by when waking up or not waking up. And then coming late to class is influenced by you missing or missing the class. So this is a direct dependence. So B depending on A, C depending on B. Now that takes us to another kind of relationship. So I've talked about direct dependence. Another kind of relationship is what we call conditional dependence. Conditional dependence. This is direct dependence, this one. But we could also have conditional dependence. Let's look at event A and C. Look at event A and C. We say that A and C are conditionally independent given B. And take note of that. What am I? Just a minute. So, actually, what I want to define here is just a minute. Sorry. What I want to define here is conditional independence. Right. Yes. So in our lecture notes, we define conditional independence, not conditional dependence. So we define conditional independence as a situation where two variables are conditionally independent if they are independent given a third variable. So as I said earlier, you need three variables to be able to explain or to be able to demonstrate conditional independence. So let's look at event A and event C. Let me ask you, if you know about, if the student, let's say you know that the student now arrive late to class. If you know the student come late to class, and you have that information from B. In other words, is from, you know that the student missed the bus. That's why the student arrived late to class. Do you need information about A? Who is going to answer that? Do you need information about A again?
No, sir.
Why?
No, sir.
Why? Why? You know that the student arrived late in class because the student missed the bus. So you are saying you don't need information about whether the student woke up late or not. So why? I want you to just say what is in your mind, gentlemen and ladies.
Okay, because there's already a direct implication of him coming late to class, which is that he missed the bus. So the information about waking up late is not really important again.
Thank you very much. And that's the point we are trying to make. So if I want to put it now, I will say the probability of the student arriving late is conditional, the probability of the student coming late, given that the student woke up late and the student missed the bus. If this probability is the same thing as the probability of the student arriving late, given that the student missed the bus. If this probability is the same thing as this, you know, I'm no longer conditioning it on A. If this probability, in other words, probability of the student arriving late, condition on waking up late and missing the bus, if is the same thing as probability of arriving late, giving only the information from the bus, then we say that we don't need the information about A. That information about A is not, you know, is of no importance. A is not even providing any useful information or additional information that will really change the narrative. So conditional independence is defined when you have event A, B, C, and the probability of C is conditioned only on B, which means you are able to do away with information from A. Then we say that A and C are conditionally independent. A and C are conditionally independent given B. A and C are conditionally independent given B. In other words, A is conditionally independent. Or if you remove conditional, there is a direct dependence. That's where I started. A can actually influence B, B can influence C. So there is a direct dependence. But when it comes to conditional independence, we now see that once B is able to give us information, we can actually do away with A. And so in this case, in terms of the relationship between A and C, then we say A is conditionally independent of C. Wow. Sorry, are you hearing me? I don't know what happened.
Yes, sir.
Yes, sir.
Are you able to see my screen?
No, sir. Okay,
Yes,
yes,
No,
sir.
we
sir.
can see it now.
Yes.
Okay, that's gone again.
Okay, I don't know what happened. The thing. Okay, great. I want to believe that that explanation is clear. Is it clear? Is it clear?
Yes, sir.
Yes, sir.
Okay. So we use a special notation to really capture that relationship. So we will say A is conditionally independent of C given B. A is conditionally, you see the way I write? A is conditionally independent of C given B, which simply means that A, once I know B, I don't really need any information about A to determine C. This is conditional independent. That is A and C, they are no, they are conditionally independent. Given B. So another way is to simply say that A, remember, is saying the student woke up late. Remember, C is saying the student arrived late. So we can also interpret this to mean woke up late and arrived late are not, independent in general. They are not they are not independent, woke up late, they are not independent. There is a direct dependence. However, we can say they are conditionally independent, given that the student missed the bus. So I want you to get, it's not that A and B, are independent. They are not independent, but they are conditionally independent. Given. So this concept is something you also need to know very well. So that's as much I will say about that. So uh, we have roughly 20 minutes more. Maybe I can stop now. The Bayes theorem. I don't know if Kafayat can talk about that briefly, fine, and then allow honey to engage them on few questions. Any question before I leave you? If none, so thank you very much. Kafayat, you have the floor. Let me stop sharing.
Thank you, sir.
You're welcome.
Thank you, sir.
Thank you very much. Thank you, sir. Good morning, everyone. So I think Miss Oni left the meeting shortly. Hopefully, she will join back before we conclude. But she told me she's having some activity shortly. So Prof discussed about conditional probabilities, independence, and I'll just give a few examples in addition to what Prof has explained earlier, just for us to widen our knowledge on the aspect of conditional probabilities and independence. But before I go there, I think last week we gave an assignment on our course manual. That's on page 20 to 21. I believe by now everybody have submitted their assignment. We gave them number 1 and 8 of the course manual. All right, so due to what we have taken in class today, the next assignment will be number 5 and 6. Yeah, 5, 6, 7. Before to be submitted on Thursday. That's before the next class. That's our course manual, page 21, number 5, 6, and 7. So that will be notified on the classroom before the next class. All right, so just one example. Yeah, before I go there as well, the Bayes theorem. Let me briefly, Prof has said I should talk about the Bayes theorem. Initially, we've been using formulas on probabilities, random variables, conditional probabilities, independence, and all of that. But let's put all of this together in one formula. And that's where the Bayes theorem comes in. Help us to reverse the conditional probabilities. That's what if we have, let's say we have 2 random variables. Let me share my whiteboard now. Okay, so kindly confirm you can see my whiteboard. Can you see my
Yes,
screen?
we can see it. We can see it now.
Okay, thank you very much. Let's say we have 2 random variables, A and B. By applying the Bayes rule, due to conditional probabilities of these 2 random variables would be probability of A given B, right? That's probability that the event A is occurring, which is conditioned on event B happening, right? Now the Bayes rule tells us that probability of, as a conditional probability of A given B equals the probability that the event B occurred given A. Remember, A and B are random variables, and Prof talked about that in the last class. Probability of B given A multiplied by probability of event A, all to the ratio of probability of event B. Now, this is the definition of the Bayes theorem. Because of our time, I'll move on shortly to an example that will incorporate both the conditional probability and the Bayes theorem. I'll be dictating the question so that we can put that in our notes, then we solve it together. Now it goes thus. Suppose there are 30% of women in a class. I'll advise that we write the question somewhere so that we can follow with the example. Suppose that 30% of women in a class received an A on the text. Let's say we're giving a test, and 30% of women in a class received an A on that test, and 25% of the men received an A. Now, we said 30% of the women received an A. In this case, women, let's say W is a random variable, right? Now, we say that probability that the woman received an A, probability that we have an A grade given women. In this case, this is a conditional probability. Conditional probability to say that the students received an A, given that all the 30% are women. That's probability of A given women. We have 0.3, right? Now, they said 25% of the men received an A. Probability that we have A, given all of them are men. In this case, we have 25%, which is 0.25. Right. And moving forward, they said the class is 60% women. That's purely probability of women in the class. That's 60%, 0.6. Now, given that a person choosing at random received an A, what is the probability that this person is a woman? This is where the conditional probability comes in. Probability that the person chosen at random received an A and she's a woman. Who can tell me what we are looking for in that case? Just unmute and then tell me what to type in this case. That's probability of what? Given that a person choosing at random received an A, what is the probability that this person is a woman? So what are we looking for in this case? Anybody? Hello, can you hear me?
So please, the question again, please. My line is
Okay. I believe you can see my screen, right? My
yes,
whiteboard.
Yes, ma'am.
Okay. The question said, suppose 30% of the women in a class received an A in a test. 25% of the men received an A. The class is 60% women. Given that a person chosen at random received an A, what is the probability that this person is a woman? So what probability are we looking for in that case?
It will be probability of woman given that they receive A. The probability of W given A.
Thank you very much, Mr. Adedemala. Thank you. That's we are looking for probability of W given A. Now, there are two approaches to solve this. Is either we use the conditional probability approach or we use the Bayes rule approach. I will solve this with the Bayes rule approach to make us get more familiar, and then you solve on your own using the conditional probability approach. Now, according to the Bayes rule, by definition, in this case, what would be our probability of W given A? That would be. Hello, is anybody saying something?
Yes.
Okay,
I
please
would
go
say,
ahead.
That's probability of A given W.
Hello,
Hello, ma. Can you hear me?
I can't hear you. Should I go ahead? Eh?
Go ahead.
Okay,
Go ahead.
Adeton, Adedoyin. You are
I'm
saying
answering the
something, right?
question.
Yes, I can hear. Okay, please go ahead. Adedoyin, you can ask the question.
No, I'm not asking question. Like I'm answering the question. I'm not asking a question. I'm answering the question.
Okay,
Like,
okay, thank you very much. Thank you very much. Okay, I
can
get
I
that.
go ahead?
I get that. All right, so using Bayes rule, the probability of W given A will be probability of A given that
W.
the students are all women, right?
Yes.
Multiply by probability of
Woman.
W. Remember, we are using the Bayes rule, and this is
Yes.
the definition of the Bayes rule. All over probability of A. Yeah, so looking at this definition, what do we have? Probability of A given W is given, that's 0.3. Probability of W is also given, that's 0.6, right? But we don't have probability of A. How then do we look for probability of A? Prof discussed this with us earlier, and that's where the law of probability comes in. Law of probability is just the sum of events involving this A. So probability of A in this case would be probability that the students got A and all of them are women. That's this P of A given women multiplied by probability that all the students are women. P of W, right? Plus probability of A given men, that is probability that all of them got A, though they are men. P of A given men multiplied by probability that all of them are men. But in this case, we don't have the probability that all of them are men. Who can tell me how to obtain this? We have P of women, but we don't have P of men. And what will P of men be? Anybody want to help with that?
0.4.
Okay,
0.4.
0.4. Thank you very much. I believe you all understood how we got to 0.4. Okay, so I will assume that P of M.
Yes.
If you have any question, just kindly unmute and go ahead. P of M will be 0.4 since the rest of them are men, right? So thank you very much for that. Right, so we now have P of A to be substituting our values in the formula above. What will our P of A be? P of A given W remember, this is supposed to be P of A given M. So P of A given W. From the question, they said 25% of the men received A. All right, so P of A given W is 0.3 multiplied by P of W 2.6. plus P of A given M, that's 0.25, right? Multiply by, that's P of M, which is 0.4. That's simply 1 minus 0.6. Okay, so can anyone help us with calculator? What will this give us? What do we have?
0.28.
0.28. Thank you very much. 0.28. Now we have, using our formula here, the conditional probability formula, Bayes rule formula rather. Remember, we are using the Bayes rule approach, or you can say the Bayes theorem approach, not the conditional probability approach. Now, substituting our values inside this formula here, we have P of W given here. That will be P of A given W 0.3, right? Multiplied by P of W, we have 0.6. Also the ratio of P of A, we have 0.25. So this someone should help us. What do we have here?
Zero point 642.
Thank you very much. 0.642.
3. Or 3.
Okay, 3. Thank
Yes.
you. So it said the probability that a person choosing at random received an A, but this person is a woman, we have 0.643, or we can simply say 64.3%, right? 64.3%. So that's our answer. Now, using the conditional probability approach, I will leave that for us to do on our own, but we must arrive at the same answer. There's something simple. In case you have any question, you can ask, or even if it's on the group, we always respond to your question. All right, so I think Miss Oni is not here yet. Okay, the last class, and Miss Oni treated the quiz with us, right? I think the kids kindly confirm we treated the quiz on page 19, right? That's the quiz for this session. Am I right?
Yes, ma'am.
Okay, thank you very much. So,
it's like Omni will not be around. Omni will not be around. I think she has a function.
okay. Yes, sir. Yes, sir.
So you
Okay,
can
sir.
just handle that.
Okay, sir. So, since we have treated the quiz already, and I would have said we treat the questions, but we already have that as an assignment. Yes, Adelusi Toyin. Your hand is up.
Yeah, sorry, concerning the solution that we just did. So the answer I got is
Okay.
0.72. So I want to confirm. That's the probability of women giving A. So, and when I did the calculation, I got 0.72.
Okay, did you use the same approach that we used here?
Yes, the 0.3 multiplied by 0.6, then divided by 0.25.
Sorry, so it should be 0.28. That's the probability
Okay.
of A. That's the point. Thank you for that observation. So if you do that, you get
Yes, ma'am.
0.643 as the probability. Yeah, thank you very much, Tony. Okay, so since we already have the questions as assignments, I think we are going to round up the class at this point. So is there any other question before we round up the class? Okay. Prof, sir, can we round up the class at this moment, sir?
Yes, we can. So
Okay, thank you very
can
much, sir.
close the session.
Okay, thank you very much, sir. All right, so the assignment was via the classroom and should also meet by Thursday. Thank you very much, everyone. We meet in the next class. Enjoy your weekend.
Thank you.
Thank you, Prof. Thank you, Ms. Kafayat.
Yeah, bye.